On a sunny Tuesday afternoon, on the northeastern outskirts of Paris, 100 passengers began the boarding process onto the world's fastest commercial plane. Navigating down the narrow body of the Concorde with pairs of business class seats flanking them on each side. Flight 4590 was a chartered flight, carrying the predominantly German passengers to embark on an adventurous journey through the Caribbean, the Panama Canal, and finally Ecuador aboard the MS Deutschland. The crew of the flight was composed of the captain, a 53-year-old pilot with over 300 hours flown in the Concorde. The first officer was a 50-year-old with over 2,000 hours of Concorde flight time, and the flight engineer who again accumulated over 900 hours of flying with the Concorde. At 2:34 p.m., ground control gave clearance for the flight to take off from runway 26R, the longest runway at Charles de Gaulle Airport, which was needed to get the Concorde's cumbersome delta wings up to takeoff speed. At 2:40 p.m., flight Air France 4590 lined up at the start of runway 26R, beginning the exciting takeoff sequence, the world's only commercial plane to employ afterburners. 20 seconds later, the first officer calls out that they've reached 100 knots. 6 seconds later, the officer calls out V1, the point of no return. Aborting the takeoff now was no longer an option, as there was not enough runway left to stop in time. A mere 2 seconds later, a loud crash is heard from the left wing, and flames are seen billowing from the plane, crashing just moments later into a nearby hotel. What followed was a multi-year air crash investigation, unraveling the cause of the accident from the wreckage using engineering. This is its story. The challenge facing air crash investigators for any tragic loss like this is immense. The Concorde had crashed into a small hotel and restaurant almost 10 kilometers southwest of Charles de Gaulle Airport. Flames had consumed the area around the crash site, leaving the investigators a scattered and scorched debris field to piece back together. The investigators started by organizing the accident site to discover clues about what had happened. Clipped trees north of the hotel crash site suggested that the plane had crashed while heading south. Following along that southward trajectory, the ruins of the Concorde's powerful turbojet engines were scattered on the darkened, burnt ground. The site was littered with large impact marks, with pieces of fuselage embedded in the ground. Further south, the main cabin was found, alongside the tragic victims of the crash. To the east lay the cockpit and its burned instruments. Not all of the instruments survived the flames, and many of them were missing. However, a few instruments did survive the crash and the heat. The investigators noted down the final readings on the dials they could read. This would hopefully provide crucial information that would lead to a revelation as the investigation continued. As they dug through the remains of the aircraft, they found the flight data recorder, the tool that stores critical data about the plane's flight record. They also found the cockpit voice recorder, allowing the investigators to listen to the plane's final moments. In these audio recordings, a large bang is heard shortly after the officer called out V1. At the same moment, the flight data recorder displayed a sudden loss of speed and thrust in engine number 2 on the left wing, followed closely by its neighbour, engine 1. While engines 1 and 2 were struggling, the data showed that the plane kept flying with an almost constant angle of attack without gaining altitude, while the loss of thrust on the left wing caused the plane to roll. This flight data and the audio recordings provided a lot of evidence as to what had happened, but it left a crucial question unanswered. What was that loud noise that preceded the fire, and what caused it? To find more clues, the investigators turned their attention to the runway. Even without the data recordings, the scorched concrete painted a vivid picture of the Concorde's final moments. It was clear from the burned grass and damaged lights that the Concorde had lost control and veered to the left, while irregular marks in the concrete and chunks of rubber pointed to a left tire failure. Along the charred trail, the plane left more breadcrumb clues crucial to continuing the investigation. Besides the damaged rubber tire, 2 other items stood out to the investigation. a mysterious titanium strip with irregular drilled holes, and an unscorched piece of the plane no larger than a sheet of printer paper. They were perplexed by that thin metal strip.
That's my real voice.
This is not my real voice.
Irregular drilled holes are not very common in the industry. This led to investigators trying to match the 42 centimeter long strip to any component of the Concorde, but they couldn't find a match for it anywhere in the design documents. They concluded that this strip was not part of the plane and had been there before the plane took off. Logically, the next step was to scrutinize all of the departing flights on the same runway to identify where this metal strip could have come from. Flight 4590 left at 2:30 p.m. They scoured through all of the maintenance and engineering documents for any plane that took off after 1 p.m. One of the many papers they went through pointed them in the right direction. A McDonnell Douglas DC-10 that was servicing a continental flight that left a mere 5 minutes before the Air France flight had a maintenance document referencing a metallic wear strip. The maintenance documents showed that the plane had undergone repairs of a metal wear strip just 1 month prior in Tel Aviv. The same document showed that the maintenance was not up to manufacturing standards. To confirm, the investigators tracked down the DC-10 and found it was missing a wear strip with the same irregular drilled holes. The culprit's fingerprints had been matched to the scene of the crime. The investigators concluded that a few minutes before Flight 4590 was due to depart, Continental Flight dropped its wear strip on the runway. Crucially, a 32 centimeter long cut was found in the rubber tire debris left on the runway. While it was tempting to connect this 42 centimeter long metal strip and the cut found in the tire, the investigators could not assume it was the cause. To confirm, investigators built a simulated Concorde, a wagon modified to fit a new Concorde tire, loaded with 25 tons to simulate the weight of the aircraft. And indeed, the strip cut the tire exactly as seen in the crash debris. However, this only answers why a tire would burst. Crucially, this does not answer how a tire burst would cause the eventual fiery crash. After all, this crash was not the first time the Concorde suffered a burst tire during takeoff. During its 30-year program, the Concorde experienced 57 tire malfunctions. 22 of these events happened during takeoff and 19 were caused by a foreign object. In 12 of these events, structural damage was seen and 6 experienced fuel tank penetrations, but none caused a fire like the one seen on Flight 4590. One event in particular stands out. On the 14th of June 1979, an Air France Concorde took off from Dulles Airport in Washington, D.C., heading to Paris. During the takeoff, one of the tires burst and caused punctures in 3 of the tanks. This led to fuel being leaked at a rate of 4 kilograms per second. Luckily, the crew noticed the damage, and 24 minutes after takeoff, they landed safely back at Dulles Airport. In the report that followed this incident, it was stated that the risk of fire was low after penetration of the tanks. They stated that the low rate of fuel leakage, coupled with scarce ignition sources, did not pose a significant risk of fire. They also stated that even in the event of a leak, the location of the tanks would cause the fuel to disperse rather than accumulate. The images and videos of the Concorde in flames play in stark contrast to the findings from this previous investigation. This, of course, begs the question: what was different about this flight that led to this infamous picture? To answer that question, the investigators needed to quantify the fuel leak rate of Flight 4590. Visual evidence that came from videos and images of the crash provided the first clues. Using these images, the investigators could estimate the dimensions of the flames trailing behind the Concorde's wing, gauging the flame to be 50 meters long, 3 meters in diameter, and 10 centimeters thick. They could estimate the rate of fuel leak needed to sustain such a blaze at 60 kilograms per second. One of the instruments that survived the crash confirmed this number. With the initial fuel load known, some simple calculations confirmed the fuel leak at a rate of 60 kilograms per second using the fuel dial, still stuck in its final position. 15 times greater than the 4 kilogram per second leak witnessed in the previous incident at Dulles Airport. This points to a very different fuel leak mechanism. Here is where the third piece of evidence from the runway helped the investigators solve the mystery of the crash. A single 30 centimeter by 30 centimeter piece of tank was found on the runway. This piece held the secrets to what happened. To an untrained eye, this piece of metal wouldn't stand out. Coated in the Concorde's white, heat-resistant paint on one side and strengthening struts running along its length on the other. This was enough detail to pinpoint exactly where in the plane it came from. Tank number 5, right above the landing gear. Next, the investigators noted that the piece was not burned at all, indicating that it dropped before the fire started. To crack the final piece of the puzzle, the investigators needed a material science expert. To an untrained eye, the fracture surface of a metal tells you little, but to an expert in fracture mechanics, it tells a story.
Pag-hit. Huwag mo nga usugan ako yung killer.
The investigators' report noted that the ruptures in the thin skin were matte for the most part. The rupture face was angled at 45 degrees, which indicates that these were static ruptures. To understand the significance of this passage, we need some background on fracture mechanics. Why does a 45-degree rupture face indicate a static rupture? Let's run a couple of examples with different materials undergoing different types of stress and see how their fracture geometries vary. The investigators knew that the type of aluminium being used in the tank was a ductile material. If we take a ductile material and apply stress to it, as its name implies, the material sample would deform as the load increases. This leads to a phenomenon called necking, where the material thins out until it can't stand a larger load and then fails. This leaves a characteristic 45-degree angle on the failed piece. Often, in these types of failures, you can see a cup and ball surface, again at a 45-degree angle. These types of surfaces only happen to ductile materials under tension. If another type of stress would be applied to the sample, say torsional stress, then the material would break with a 90-degree angle. Examining the fracture surface of this piece told the experts working on this case a story. The hole in the tank wasn't caused by a puncture by the tire physically piercing the tank. It pointed towards a rupture caused by a buildup of pressure inside the tank. The piece of rubber hit the underside of the wing with enough force to cause a deformation in the tank, causing the walls of the tank to bend in while adjacent sections bulged out. This was a serious problem because the fuel was incompressible, and being the start of the flight, the tanks were full. The resulting pressure wave slammed down into the bulging sections and ejected the piece of tank found on the runway. And a hole this large was capable of causing a fuel leak large enough to match the flames seen in the images of the tragic accident. The scene was set. A poorly positioned metal strip caused a stressed tire to burst and slam against the underside of the wing, which in turn led to a massive pressure wave inside the tank, which ruptured the tank, leading to a catastrophic and tragic loss of power, leading to the plane's uncontrollable descent. A decade-long legal battle ensued between Air France and Continental, where they took turns pointing fingers at each other, finalizing in a 2010 court ruling that fined Continental €1 million. Plans were made to add Kevlar liners to the fuel tanks to prevent further static ruptures like this, and potential electric ignition sources were also moved and reinforced in the area. New damage-resilient tires were also introduced. However, these modifications meant little for the financially struggling Concorde. This crash proved to be the final nail in the coffin for the airline. With high ticket prices and low demand for flights becoming even lower in the wake of the crash, the Concorde proved to be financially unviable, leading to both British Airways and Air France to cancel their supersonic flying programs, the end of an era marked by a tragic crash.